Hello everyone. Today I'm going to present my project Email Spam Filter. As emails become our major way of communicating with each other, we start receiving more and more spam emails. That's why I want to build a email spam filter based on neural networks. First is my framework selection. I chose Keras since it's built upon TensorFlow. It uses my CPU to perform the training and testing, and it's written in Python. Here, this is a model construction part. Here is a sequential model, which is fairly simple. I have an input layer, an embedding layer, an LSTM layer, a dense layer, and an output layer. I'll go into the details of each layers. The first layer, the word embedding layer, is basically a function to map a word to a high dimensional vector. It often leads to better performance with RNN. Here, this is a graph of the CBOW way of word embedding. It's called continuous bag of words. So basically, it's one way to do the word embedding, and we can see here are the inputs x1k, x2k to xck. Those are all words, and they are fed into the hidden layer and calculate the average of them. Then we get the output, which is an n times v dimensional matrix. And here, this is the LSTM layer. It consists of a cell, an input gate, an output gate, and a forget gate. LSTM has feedback connections since it's a special type of RNN. Yep, and it's good with the exploding and vanishing gradient problems such as speech recognition, all those NLP type of problems, and text classification. Here, Here is a LSTM unit. As we can see here, this is the forget gate. So it basically decides that whether we want to keep the old information or remove it. And those two are the inputs, the historical inputs and the current input. And here we have the input gate layer. It has a sigmoid function and a tanh function. It determines whether we want to use the new input information or we just simply ignore it. Finally, this is the output layer, output gate, the tanh function, a sigmoid function, and a sigmoid function. It filters out the information we don't need and only output the information that we want. For instance, if we ever want to know if we have a sentence and we want to know the verb that comes next to the subject, then we better output whether the subject is singular or plural, so we can know the verb form that comes next. Yep. And next is a dense layer. It's basically a fully connected neural network layer with activation functions. It's just a regular neural network layer, and the activation function I chose is sigmoid, since it's a binary classification problem. And here, this is my parameter tuning part. I have a batch size, learning rate, hidden units in LSTM layer, and epoch. So the batch size I chose is 32, which I always use as my starting default batch size. And the learning rate, since I'm using the Atom optimizer, I just started with the default learning rate. But then I find it's too large. I have to tone it down. And the hidden units in LSTM layer, this one I chose is 128. The epochs I chose is 5 to start with. here, but then I start having the overfitting problem. As you can see, the training loss and the validation loss is not converging. You see here, yeah, and it passes the point that they converges, which is not good. So I decided to either increase data size or simplify model structure, reduce learning rate, implement early stopping, and add regularization. So I didn't find a way to increase my data size, so I basically simplify my model structure by decreasing the hidden units in my LSTM layer from 128 to 80. Also, I reduced my learning rate from the default 0.001 to 0.0001. And then I also implemented early stopping. So what it does is basically if the validation loss does not decrease for more than 2 epochs, then the training will stop. So it prevented from overlearning it, basically overfitting it. And then the final method I use is called regularization. It's in Keras, it's called dropout. So it basically randomly drop out some values between each layer. The value I chose is 20%. So it will randomly drop 20% of inputs between the layers. After I do that, here's my graph. You can see now they converges pretty well. Yeah. And the result I got is a false alarm rate of 4%. I listed the false alarm rate because I think it's fairly important. The false alarm rate is basically the rate that is supposed to be a ham email, a normal email, but then we treat it falsely as a spam email. I want that rate to be as low as possible because we don't want important emails to go into spams. We'd rather sacrifice some to let some spam emails come into our email box rather than important emails go into the spam box. Yep. So at first it's like 27, 28%, which is too high. That's why I did. That's also why I did all the adjustments. It goes down to 4% now, and the total test accuracy now is 97.35%, which passes the 95% goal that I set up. So the model works fairly nice. Yep. So basically, the data I use is called the Enron spam datasets. It has over thousands of spam emails and ham emails. So yeah, I did some data cleaning, data preparation to make the data vector of to make the data from text to matrix of numbers, so it can be fit into the model. Yeah. And finally, I got the results by computing the confusion matrix. Here, I'll show you the code, run the actual text program. Yep, it's running right now. I have the models pre-trained, so it's faster that way. Otherwise, it's gonna take hours and hours to train the model. So now I just have to load the model and run the test data through the model. Alright, as we can see, we're done with the testing process. First, we got a confusion matrix. In the first row, the first column is 309, which means we have 309 emails that are supposed to be ham emails and are treated as ham emails. And then for the second column, we have 13 emails that are supposed to be ham emails but got mistreated as spam emails. And then for the second row, first column, we have 4, which is 4 emails that are supposed to be spam emails and got mistreated as ham emails. Finally, the 315 emails that are supposed to be spam emails and got also treated as spam emails. And then we can see our final test accuracy is 97.35%, 0.97347. Yep. So, yep, basically that's it. Thanks for watching.